Now, there are some property related to Laplace transform. First one is multiply by t property. If Laplace ft is equal to f bar s, then Laplace t ft is equal to minus d by ds f bar s. Now, there is another property. If divided by t property, if Laplace ft is equal to f bar s, then Laplace ft by t is equal to s to infinity f bar s ds. Here is some another property, multiplication by t to the power n. If Laplace ft is equal to f bar s, then Laplace t to the power n ft is equal to minus 1 to the power n d to the power n upon ds to the power n fs. Now there is another property, Laplace transform of derivatives. If Laplace ft is equal to f bar s, then Laplace f dash t is equal to Laplace d by dt ft is equal to s f bar s minus f0. Here f0 is equal to limit t tends to 0 ft. If Laplace f dash t is equal to s f bar s minus f0, if here is Laplace f double dash t, then s square f square, sorry, s square f bar s minus s f0 minus f dash 0. And when Laplace f triple dash t, so it will be s cube f bar s minus s square f0 minus s f dash 0 minus f double dash 0. Another property, Laplace transform of integral. If Laplace ft is equal to f bar s, then Laplace 0 to t integration ft dt is equal to f bar s by s. Laplace transform of the nth order derivative of function of t. Let the derivative of ft is f dash t, f double dash t, and so on fn minus 1 t. T tends to infinity if fn t is equal to Laplace fn t, which is equal to Laplace fn t is equal to s to the power n Laplace ft minus sn minus 1 f0 minus sn minus 1 f dash 0, and so on minus fn minus 1 0. The initial value theorem, limit t tends to 0 ft is equal to limit s tends to infinity s Laplace ft, and final value theorem, limit t tends to infinity ft is equal to limit s tends to 0 s Laplace ft. Evaluation of integrals. If Laplace ft is equal to f bar s, that if integration 0 to infinity e to the power minus st ft dt is equal to f bar s, taking limit s tends to 0, so 0 to infinity integration ft dt is equal to f bar 0. So the question is, given Laplace sine under root t is equal to under root pi by 2p 3 by 2 e to the power minus 1 by 4p, show that Laplace cos under root t by root t is equal to under root pi by p e to the power minus 1 by 4p. अब यहाँ पे हम p की जगह पे s भी लिख सकते हैं. सो ऑन फॉर सॉल्विंग दिस इट इज़ गिवन दैट Laplace sine under root t is equal to under root 1 by under root pi upon 2s 3 by 2 e to the power minus 1 by 4s. Let ft is equal to sine under root t. इसका f डैश फाइंड करेंगे, सो f डैश t, इसका डिफरेंशिएशन करेंगे, सो वी विल गेट cos अंडर रूट टी अपॉन 2 अंडर रूट टी. सो f0 is equal to sin 0, which is equal to 0. Now Laplace f dash t is equal to s Laplace ft minus f0. So Laplace cos under root t upon 2 under root t is equal to s Laplace sin under root t minus 0. f0 की वैल्यू क्या निकली थी? 0. सो हमने वो यहाँ पे पुट कर दी. नाउ which is equal to s under root pi upon 2s 3 by 2 e to the power minus 1 by 4s. So Laplace cos under root t upon 2 under root t, which is equal to 1 by 2 under root pi upon s 1 by 2 e to the power minus 1 by 4s. So Laplace cos under root t upon under root t is equal to under root pi by s e to the power minus 1 by 4s. Now there is another question. Find Laplace integration 0 to t sin x by x dx. So for solving, we know that Laplace sin x is equal to 1 by s square plus 1. Now using property of divided by t, Laplace sin x by x is equal to s to infinity 1 by s square plus 1 ds. So on integration we will get tan inverse s to infinity limit. Now on putting these limits, so we will get tan inverse infinity minus tan inverse s. So tan inverse infinity is equal to pi by 2, or it will be minus tan inverse s. So pi by 2 minus tan inverse s is cot inverse s. Using integral property, Laplace 0 integration 0 to t sin x upon x dx is equal to cot inverse s by s. Now there is a question. Evaluate integration 0 to infinity e to the power minus at minus e to the power minus bt by t dt. Now let ft is equal to e to the power minus at minus e to the power minus bt. So Laplace ft is equal to 1 by s plus a minus 1 by s plus b, which is equal to f bar s, say. Using divided by t property, so Laplace ft by t is equal to integration s to infinity 1 by s plus a minus 1 by s plus b dx, which is equal to log s plus a upon s plus b लिमिट s to infinity. इसका इंटीग्रेशन कर दिया. नाउ इट विल बी log 1 प्लस a by s upon 1 plus b by s minus log s plus a upon s plus b limit s to infinity. On putting these limit we will get log 1 minus log s plus a upon s plus b. So log 1 की वैल्यू 0 minus log s plus a upon s plus b, which is equal to log s plus b upon s plus a. Thus Laplace ft by t is equal to 0 to infinity integration e to the power minus st into e to the power minus at minus e to the power minus bt by t dt, which is equal to log s plus b upon s plus a. Therefore, taking limit as s tends to 0, we have integration 0 to infinity e to the power minus at minus e to the power minus bt by t dt is equal to log b by a. Now there is a question. Show that integration 0 to infinity sin t by t dt is equal to pi by 2. We know that Laplace sin t by t, we know that Laplace sin t is equal to 1 by s square plus 1. Using divided by t property, Laplace sin t by t is equal to integration s to infinity 1 by s square plus 1 ds. On integration we will get tan inverse s to infinity limit. So on putting this value, pi by 2 minus tan inverse s, which is equal to cot inverse s. Now by integral property, integration 0 to infinity sin t by t dt is equal to 0 to infinity integration pi by 2 minus tan inverse s. And if s tends to 0, so it is equal to pi by 2. 0 to infinity integration sin t by t dt is equal to pi by 2.